In lesson 2, we're going to focus on the standard form of a quadratic function, and this is the one that you're most familiar with seeing from Algebra 1. So it's been a minute since Algebra 1, so this will include a lot of review. But again, we're going to practice so that we can handle the quadratic functions in either form. We've already spoken about vertex form, and that was actually not too bad. You all did quite well with that. So let's go ahead and check out what we do in lesson 2. We're going to write and graph these functions in their standard form. Still the same vocabulary, except instead of vertex form, we've got standard form. And just again, a recap of this concept. We are familiar with vertex form. We've been exploring that here in this course, but this is work that you used in Algebra 1. We would graph this function by finding the axis of symmetry. X is equal to the opposite of b over 2 times a. We'd use that as our axis of symmetry. We'd plug in that x value. That would give us the y. That's our vertex. And then we would build our table of values from there. We're going to operate pretty similarly this time, except that since we understand a bit of the transformations of these quadratic functions, once we locate the vertex, we can kind of build our points, plot our points using the a value and what we understand about the graph of the parent function y equals x squared. So it'll be faster than it was in Algebra 1, I'm hoping. And if not, we can plot along and do the hardcore work. What I wanted to show you, though, is this connection between how we get from here to there. And so what I wanted to show you was, what if we actually expanded this out, this x minus h times x minus h, and squared this binomial, multiplying it by itself, so that we get x times x, x times h, and another x times h. So there's two of them that are negative. And then h times h makes a positive h squared. Distribute the a inside, and so we have ax squared, 2 minus 2ahx, and then plus ah squared. And then, of course, the plus k is on the outside. So working this through algebraically and expanding it out, we find that a here is the same as the a there. These are the same a's. But the b value is this negative 2ah, 2 times a times h. And then the c value is this whole sum, ah squared plus k. And this h squared is, again, we know what h is in terms of the b. At least we can solve that. So what I wanted to show you, and this is just some math magic, it's just awesome algebra. And I know that might seem a little terrifying to you, but when we do this awesome algebra, we can see that if I know what b is in terms of a and h, I can find out what the h value of our vertex is, right? What's the x value of our vertex, h, by dividing by -2 and by dividing by a. So this will become the denominator. This will become the opposite of b over 2a. That's our h value. Now, you already saw us explore that with that axis of symmetry. X is equal to the opposite of b over 2a. We're still exploring that. But over here, look what happens with our c value. I'm sorry, with our k value. If we subtract a times h squared, we get what k is, the y value for our vertex. However, this isn't expanded, this is in terms of h, and what we want to be able to do is define k in terms of a, b, and c. And so we've multiplied this out, we distributed, or not distributed, but we multiplied this opposite of a into here, and so we get the opposite of b squared divided by 4a. All that I'm wanting to show you here is kind of some step-by-step algebra, one that you're completely capable of doing, but also to kind of maybe make the next part a little more palatable for us, all right? A little more enjoyable, a little more doable. So I want to make sure that we can handle what we see here on this next slide. And that is, once we know what our axis of symmetry is, that negative b over 2a, or the opposite of b over 2a, we're going to take that number and just plug that into our function. We're going to substitute that value, we're going to square it, multiply by a, we're going to multiply it by b, and then we're going to add these three terms together to find our vertex. I think that this will be a lot easier for a couple of reasons. One, this is how you've approached it in Algebra 1, and I want to model that for you again here, just to remind you of that work that you've already done. And two, it's one less formula to really remember or memorize. This opposite of b over 2a, we're going to see that a lot as we continue to explore quadratics. And so I think that will be manageable for you. And I think it'll be much more manageable than trying to remember this along with that. All right, so kind of one thing at a time might make things more manageable, again, for you. If you want to use the other method, that's totally fine, but you're going to see me in my examples use this approach. So, given the standard form, we want to be able to identify A, B, and C, and we want to be able to graph these parabolas. And so in order to do that, we're going to find that x is the opposite of b over 2a, or in this case, the opposite of -4 over 2 times 1/2. So x is +4 over 1, which is 4. Once I know where my vertex is going to be, I can locate what the y value for my vertex is going to be by substituting, basically, well, I'll do it says instead of y, I'll put f of the h value, f of 4, and I'm going to plug that number in and let my calculator do that work for us. So half of 4 squared, half of 16 is 8. 8 minus 16 is going to be -8. So 8 minus 16 is -8. -8 plus 8 gives us an output of 0. So the vertex is at 4, 0. With that, we know our a value is 1/2. So instead of going over 1 up 1, I'm going to go over 1 up 1/2. Instead of going over 2 up 4, we're going to go over 2 from the vertex up 2. Instead of going over 3 up 9, I'm going to go over 3 up 4.5. And instead of going over 4 up 16, I'm going to go over 4 up 8. We're multiplying all of those values by 1/2. And that gives us this parabola, this U-shaped graph that's a little squished down just a little bit because of this a value being 1/2. All right, let's try this one. Here, a is -2, b is 6, and c, there's nothing being added here, so we know that c is equal to 0. All right, again, that's not super relevant when we know that we're just going to use the opposite of b over 2a. So in this case, the opposite of 6 over 2 times -2. So x is -6 over -4, which is +1.5. All right, 1.5. To find out what happens when I substitute that value in, I'm going to, again, use my calculator to do this math to make sure that we add and multiply correctly. So here we have let's see, we got 3/2 squared, which is 9/4. 9/4 times -2 is going to be -9 over 2. And then 6 times 3/2 is 9. So we get 4.5. We get 9 over 2. So 4.5. 1.5, 4.5 is our vertex. So at 1.5, 1, 2, 3, 4.5, we have our vertex. Now from there, we're going to go over 1, and this is tough, over 1, down 2. Instead of over 1, up 1, we're going to go over 1, down 1, 2. Instead of going over 2, this is tough for me, down 4, we're going to go over 2, down 1, 2, 3, 4, 5, 6, 7, 8. And instead of going over 3, down 9, we're going to go down 18, and that's going to take me too far. So it's going to take me beyond this, this coordinate grid. So I'm going to do my best to sketch this, all right? And that will be the graph of our parabola. All right, wonderful stuff. A little bit difficult there because we're dealing with decimals, but we can plot those decimals. This is all an approximation of how we are graphing these parabolas. There's 2 that we're going to do next, and actually I'm going to do one of them and I'm going to have you do letter D. So you do this one. Just try it. You might find out that you like it. Here A is 1/3, B is 0, and C is 2. So I have x is equal to the opposite of b over 2a. X is the opposite of 0 over 2 times 1/3. Well, this is going to give us 0 in our numerator, so I don't have to worry about the 2/3 in my denominator, where the opposite of 0 is just 0, so x is 0 is going to be where our vertex is. When I substitute 0 in, I get 1/3 of 0 squared plus 2. Oh, it turns out that our vertex is the y-intercept. All right, 0 plus 2 makes 2. So 0, 2 is our vertex. From there, we have this vertical compression of 1/3. So instead of going over 1, up 1, I'm going to go over 1 only up 1/3. Folks, you're approximating this. Where the 1/3 is, it's less than half, but it's more than a quarter. I don't know, do what you want to do. Over 2 up 4. Instead, we're going to go over 2 up 4/3, right? Which is 1 1/3. Over 3 up 9. Instead, we're going to go over 3 up 1/3 of 3. I'm sorry, 1/3 of 9, which is 3. And then we can continue on from there if we want to. Over 4 up 16, but we're going to go 16 over 3, which is 5 1/3. And maybe we can go farther. Well, we're just going to do this. And this is a really wide parabola. There we go. All right, so here we've made our table of values. Now, if you, this is okay if this is you, if you struggled with finding those x comma y's, sometimes I do too, maybe I even messed up one of these, all right? Correct me in the video if I'm wrong, just let me know, like, this is if you did all that math wrong. You can check in your calculator, right? You can type all those in, and you can say, well, what happens if I know what happens at 0, what's gonna happen at 1? What's gonna happen at 2? What's gonna happen at 3? What's gonna happen at 4? And it will give you those outputs if you plug in 1, 2, 3, and 4, or -1, -2, -3, -4. The cool thing is that if you're making your table of values, if you're using your calculator, if you know what happens at 2, then in this case, on the opposite side of the axis of symmetry, you know what's going to happen at -2. Because it's going to be symmetrical. It's going to have the same y value for those corresponding inputs. All right, so if you put in -2, you're going to get out the same output as you did for +2. And that's obviously if the AOS is at 0. If the axis of symmetry, like the last one, was at 1.5, then you could check what happens at 2 and what happens at 1. And you're going to see the same output there. What's going to happen at 3, what's going to happen at 0, they're going to have the same outputs because they're equidistant from that vertex. All right, so let the calculator do some of that computation for you, and you should be good. Or you can consult the table. Obviously, we want you to be able to graph this without using the grapher. That's kind of the point here. But we also want to expedite the work when it's necessary to expedite it. All right, now applying this. All right, and I know that we get freaked out about word problems, but then we also try to, not engage with the content by saying, when am I ever going to use this? Well, here's where someone in business is trying to maximize their profits. And if you work for a company and they want to maximize their profits, and you're like, yeah, I don't do math, they'll be like, okay, well, find a different job. But here, you want to price your headphones in such a way that you don't price them too low so you're not making a lot of money, and you don't want to price them too high that people aren't going to buy them. So the research here is showing that if you price them just right, then you can get the most amount of money for that product, all right, for that run of however many you're making. So the graph is based off of this function, which is kind of crazy, right? It's a lot. Those are big numbers. Oh my gosh, what are we doing? Obviously, we want to sell for a certain amount of dollars. We want to make a certain amount of thousands of dollars of profit. Woohoo! So what's the maximum profit that they can earn? All right, well, if we want to maximize that profit, we're not going to just look over here and guesstimate what that is. Instead, we're going to find that y value of our vertex. So really what these questions are generally going to ask, if they're asking about a maximum or a minimum, that's going to be the y value of the vertex. The y value of the vertex. All right, there's my awesome handwriting. All right, but in order to do that, we need to do the x value of the vertex. And then once we find that, then we can do f of that opposite of b over 2a. All right, so that's really the direction that we're headed here. So the opposite of b over 2 times a gives us 700 over 20, which would be what? 5 times 7 is 35. All right, so it appears that 35 is going to be the magic number. So now what we want to do, and now I'm going to have to use a calculator. I haven't used a calculator this whole time, but now I got to use one. We're going to take 10 times 35 squared, and we're going to take 700 times 35, and then we're going to subtract 6,000 to figure out what that value is going to be. I'm going to use the old school calculator, not because I'm old school. Actually, I really hate this calculator. I think it's terrible, but that's just my opinion. We're going to take -10 times 35 squared, all right, and then we're going to add 700 times x, 35, and then we're going to subtract 6,000. And it tells us that the max profit there is 6,250. 6,250. We're letting the calculator do that work. All right, we obviously have to tell the calculator what to do, so that's what's important that we know how to use that. So, what's the maximum profit? Max profit, we give it a word problem, we answer with words, is units 6,250 bones. All right, there you go. That is the answer to this real world connection. Whether or not this is accurate information, I don't know, but it works. We can use a parabolic model, all right, a quadratic model, to figure out the maximum profit in that case. All right, how about this? A concert venue's profit depends on the ticket price, right? That stuff matters. So here we don't have a picture, but we're going to say whatever we set the ticket price at is going to dictate what our profit's going to be. All right, if you price them too high, people are like, I'm not going to go see In Sync for $7,000 a ticket. Maybe you're like, I would pay that much for Taylor Swift. But here we go. Let's go ahead and figure out what the right ticket price is in order to maximize that profit. So really, this first question, what's the ticket price, is, what's the ticket price? This is the opposite of B over 2A. What's the maximum profit? That's going to be F of the opposite of B over 2A. I want you to try this. I want you to try it. All right, because I like you and I think that you deserve it. I think you deserve the opportunity to practice this. So again, identify what A is, what B is, and what C is. And once you've done that, you can find out what the ticket price is going to be for the first question, and you can find out what that maximum profit is for that second question. You can try that. We will go over that one in class. I do have one more, but I'm not necessarily interested in doing that. I think that if we've practiced a couple, we've probably covered our bases, and that's obviously what I want for you, is that we cover our bases. We're going to skip that one and head on to this one. So hopefully now you feel comfortable writing and graphing quadratic functions in standard form. We didn't do too much with the writing. We did a lot of graphing. We'll talk about writing those functions on the part 2 video.